Welcome to Chapter 9. This is Lesson 9.1, Quadratic Graphs and Their Properties. Now, if you remember from Chapter 8, we call something quadratic when its variable has a power or degree of 2. The standard form is ax squared plus bx plus c. Just like when we had equations of the line, quadratic functions can be written differently. So you always know it's quadratic when the degree of the expression or the equation is a 2. So when the variable's highest exponent is 2. Quadratic functions are always graphed as a parabola. A parabola is a U-shaped curve. It can be opened up. It can be opened down. But notice over here on the bottom right-hand corner, we have this graph. Now, this is not a function. Remember, if something's a function, it would pass the vertical line test, which means you could draw a vertical line through it, and it would only cross the graph once. Here, it crosses 1 time, 2 times. So this one is not a function, so we will not be dealing with graphs that open to the right or the left. We will only be looking at functions that open up or open down. Each function will have an axis of symmetry when you graph it. Now, an axis of symmetry divides the parabola into equal halves. There's symmetry, kind of like if you had a butterfly. We used to paint half of butterflies, then fold it and open it up, and we'd have 2 equal halves that looked exactly the same. That's symmetry. So the green lines in both of these graphs split it in half. Our axis of symmetry here is x equals 0. So at the line x equals 0, we have our axis of symmetry. And here our axis of symmetry is at x equals positive 2. At our axis of symmetry, we can find something called the vertex. The vertex is the highest or lowest point of the parabola, or you can say the hump of the parabola. Now, notice here again, our axis of symmetry was at x equals 0, this line, and at this line, we hit our vertex, So our vertex for this graph is 0, 0. Remember, it goes x, y. And here, again, our axis of symmetry was at x equals 2. And we can see that our vertex is at 2, 1. Again, x, y. A little hint for you guys. Whenever the a, remember our equation is y equals ax squared plus bx plus c. Anytime that the a is a positive number, our graph will be open up. And anytime our a is a negative number or less than 0, our graph will be opening down. The last thing to note is that when we are looking at our vertexes, we will see something called a minimum or a maximum. A maximum means that the vertex is the highest point of the graph, and a minimum means that the vertex is the lowest point of the graph. So let's go ahead and do a little application here. Graph the function 1/4 x squared minus 3. Now, first thing that we will notice is that our a, or the term in front of the x squared, is a positive number. Yes, it's a fraction, but that's still positive. So that means that our graph is going to be a U-shaped graph. To solve for all of our points, again, we're going to use that same method that we usually do, where we're going to use the numbers -2, -1, 0, 1, and what color should I use? Orange. And 2. Those are going to be the numbers that we plug in for x to solve for y. The cool thing about parabolas is that we don't need to use all 5 of those points. For this specific graph, our vertex is going to be at 0, or our axis of symmetry is at 0. So I always start with my axis of symmetry. I'm going to go ahead and plug in 1/4 times 0 squared minus 3. That equals 1/4 times 0, which is just 0 minus 3, which is -3. Now I'm going to go one in the other direction. I like positive numbers. They're easier. So let's go 1/4 times 1 squared minus 3. There we get 1/4 times 1, which is just 1/4, minus 3. In order to subtract fractions, we need to give them common denominators. So I will multiply my top and bottom by 4/4. And that gives us the new equation, 1/4 minus 12/4. And we will get -11/4. Now, -11/4 written as a mixed number would be -2 3/4. Okay, I always want to do that so I know right about where I'm going to graph it. I'm going to graph it in between -2 and -3. Now let's move on to our next one. We have 1/4 times 2 squared minus 3. So that is 1/4 times 4, or 4/1, minus 3. That gives us 4/4, which is just 1 minus 3, which is -2. Now we have 3 points. Remember, our axis of symmetry means that it splits our graph in half, and each side is symmetrical. So, if we go to -1, this point will also be -2 3/4, or -2.75. And 2 away from our axis of symmetry, again, will be -2. So our axis of symmetry just kind of splits it in half. It folds it over. 2 3/4, -2 and -2. Now, don't freak out. I just transferred all the data. Here, those give us our points. When we plugged in -2, we got -2. When we plugged in -1, we got -2.75. 0, -3, 1, -2.75, 2, -2. So again, those are going to be the points that we plot. I always like starting with my vertex. So at 0, -1, 2, 3, we will plot a point. At 1, -2.75 is about there. And we can fold it over on our axis of symmetry, and we'll see that at -1, we will also have -2.75. Then at 2, we will go to -2. And again, at -2, we will be at -2. Once you have all of that, we will draw our parabola through. Remember that it is a parabola, so it will make a U shape. It did exactly what we expected it to, opening upwards because A was a positive number. And that is what our graph will look like. Let's note a few important things. First of all, our vertex it is at the point 0, -3. And our vertex, does it form a minimum or maximum? Well, the vertex is the lowest point on the graph, so it forms a minimum. Domain and range, it will ask you to find those. Domain, again, review, is all of the possible x values, and range are all of the possible y values. So if we're trying to find our domain and range of this particular function, we're going to look and we're going to say, okay, if I went off into infinity, what are all of the possible x values? Now, you may not be able to tell. I don't know why I said tell that way, but it looks like this is just going to go up forever and it will never get larger in our x values. but it's really going kind of slanty like that. It's going kind of out. So our domain is going to be all real numbers. They can be all positive numbers, and they can go to be all negative numbers, because no matter how much we zoom out, it'll always go a little out more. Our range, however, is a little different. We will notice that it never, ever, ever gets smaller in our y-axis than -3. So our range for this particular function is y is greater than or equal to -3. So, joke of the day. What did Little John do when the hardware store employee tried to sell him a light bulb? Anyone? He turned down for what? Light bulb for what? / there's a song. Hope you get it. Haha.